Our topic for today will be Newton's law. Let us understand this law. So, this is the law of motion. Now, let us start with the first law. So, this is the first law. So, law of inertia, this is the first law. It states that the object at rest will remain at rest and the object in motion will remain in motion unless acted upon by any unbalanced force. Okay, so I guess it would be wise for us to start first with the definition of force. What is a force? So before we will proceed into detail and understand further this first law, let us first understand what is a force. Okay, so let us first understand the meaning of the force. So what is a force? Hmm. What comes in our mind when you hear the word force? Well, in general, when we say force, it's either okay, so it's either a push, could be a push or a pull. What do we mean by this? This is our definition of the force. So it could be a push or a pull. Let's say we have here a box. Okay. Now suppose we have here a rope and we also have there a rope. Okay. If someone is pulling this rope in this direction, so it means that this person A is exerting a force. Okay, so it's doing some force. On the other hand, if we have here someone pushing this box in this direction, so this means that this person B is exerting a force since this one is pushing and this one is pulling. So that is um, a virtual representation of what do we mean by force. So it could be a push. So when we push something, then that is a force. And then if we pull something, then that is also a force. Now, let's say we have another example. So we have because we have also another definition for force. Let's say we focus on the box. Let's focus here on the box. Let us understand what's going on here on the box. Let's say after person A exert force and person B exert force, the box now move along this direction by a certain, so let's say certain amount of acceleration, let's say 1 meter per second squared. Now, if the mass of the box is, let's say, 50 kilogram, then find um, the force. So the force here can be found using this equation. So this is another definition for force. Force is mass times A. So mass of the object multiplied by the acceleration of the object. The acceleration of the object here is 1 meter per second and the mass is 50 kilograms. So we end up with 1 meter per second squared will end up with 50 kilogram meter per second squared, or this is 50 Newton, since Newton is equivalent to kilogram meter per second squared. So this will be the force. So this is another way for us to define what is force utilizing this equation. Let us further understand force. We have what we call net force. Net force. So what do we mean by that? When you hear the word net force, all we have to do is get the sum. So net force is nothing but the sum of all the forces along a particular direction. Right? Let's say so this is normally represented by this equation. Net force is given by this equation. So suppose we wanted to know the net force, all we have to do is simply get the sum. We could say net force along x, or we also have F net y, and we also have here F net z. Okay, so the same meaning, but in different direction. Okay, now suppose we have here, let's say, another box, and we want to know how to get the net force. Suppose somebody is pulling the box in this direction. Let's say this is our force 1, and we have another somebody is pulling the box in this direction. This is our F2, and suppose we have third person pulling the box at a certain angle, okay, along this direction. So let's say this is our F3. So if we want to know the net force, all we have to do, let's say we will focus here only in 2 dimension. So if we want to know the net force, so we will have to get the sum. So if I want to know the net force along x, then I have to find or get the sum of F2 along x direction plus F1 along x direction plus F3 along x direction, and so on and so forth. So this is n along x direction. For Fy, since this is in 2D, all I have to do is the same. F naught along y, I will have to get the force 2 along y direction. Same for F1 along y direction. Same for F3 along y direction, and so on and so forth. If we still have here another force. So this is how we are going to solve the net force. Okay, and that is a net force. It's nothing but the sum of all the forces that acts on the object. Now we have also what we call um, unbalanced force. What do we mean when we say unbalanced force? From the word unbalance, meaning when we say unbalance, the definition here is that the F net is not equals to 0. Okay, That's the definition of this one. This if we have an unbalanced force, meaning our F net could be equal to any value except 0. Okay, and that is our definition for F net or unbalanced force. Okay, let us go back to our first law. So just like earlier, we defined the first law as this one. So it states that the object at rest will remain at rest and the object in motion will remain in motion. Let us clearly understand what this law means. Suppose we have here a rock. Let's say that's a rock. Okay, just imagine that this is a rock. You have rock here sitting still. Okay, now this is actually at rest. If no force acts on the rock, okay, if there are no force acting on the rock, meaning if we don't have this arrow, because this arrow serves as our force, if we don't have any force, we remove this arrow because this represents the force. If we don't have this one, if we don't have any unbalanced force, meaning that the object is at rest and then the object will forever be at rest. Okay, it will just remain there for infinity. Okay, on the other hand, let's say we go into the outer space. So let's say we are already in the outer space. Okay, so we are at the outer space. Let's say you have here a bullet, you fire a bullet in the outer space. Okay, this is just an example. Let's say, or you just any object, you throw an object in the outer space, and then this object is moving along this direction. What we will going to notice here, because this is an outer space, so we don't have any friction. Okay, we will assume that there's no friction, and therefore this object will move at a constant rate. What do we mean by constant rate? Meaning our velocity is constant. Okay, so it will move forever so long as there are no obstacles here infinitely. Okay, and if this is the case, then our acceleration is actually zero because we have a constant velocity. Okay, you have object at rest, it will be forever at rest. And if you have object in motion, so long as there's no unbalanced force or friction, then it will stay forever in its state of motion. Now, I know that you're familiar with this one. You would notice that when you are riding a bus, okay, so suppose we have here a bus, okay, a passenger bus. Okay, now you would notice that when the bus starts to move, so when the bus starts to move, the passengers here, so let's say we have your passenger, the passengers on the bus or in the bus will tend to move backward. So as the bus starts to move, so it moves in this direction, our body tends to move backward. Why? Why do we move in the opposite direction? And the answer to that is our body doesn't doesn't like change. So it will remain to its it will try to remain okay it will try to remain it will try to remain in its initial state of motion. Since our body is at rest initially, our body wanted to stay at rest. That's why as the bus moves in this direction, our body tend to move backward because we don't like change. We want to stay at rest. Okay. On the other hand, let's say we will going to change the scenario. Suppose that the bus now is already moving at a constant rate. So since the bus is moving at a constant rate, then the passengers here are also moving at a constant rate. Now, if the bus suddenly stops, what will happen to the passengers inside the bus? So the passengers inside the bus will tend to move forward. But the question is why? So when the bus is already moving at a constant rate and then it suddenly stops, so when the bus suddenly stops, then the person or the passengers inside will tend to move forward. The question is why? Well, the answer is it's because our body is actually initially in motion and we don't like change. That's why when the bus stops, our body wanted to still to move along this direction because we don't like or the body doesn't like change. Okay, so it will remain in motion. But since we have an unbalanced force, that's why this will not forever attain. So from a particular time, the body will tend to move or tend to stop. So that's the first law. By the way, if we further generalize the first law, so if we could generalize, we could put the first law, the law of inertia. So since this is law of inertia, into a general equation, this is nothing equivalent to this one. This can be summarized using this equation. So the first law is only applicable when the F net is zero. If the F net is zero, then that's the time that this law of inertia is possible. Meaning, the F net is zero, our velocity is constant. Okay? It could be either the object is at rest or moving at a constant rate. Okay? So that's the consequence if the F net or the net force is zero. The second law of Newton is law of acceleration. So what is this law of acceleration? So this will be our second law. Well, this law of acceleration can actually be simplified or put into an equation. So this law of acceleration is nothing but F, F over m. So this is the mathematical representation of the second law. So the law of the acceleration states that acceleration states that acceleration is directly proportional to the force, okay, applied, or it could be a net force, net, and inversely proportional to the mass of the object. Okay, so let's say you have here another box. So let's say we have a box. We have box again. Okay. Now, if we have a force that is pulling the box along this direction, let's say F1, right? And if the box from point A it moves to point B, so the box now is already here. The box now is already here. Now the question is, how much is the acceleration of the box? How do we solve for the acceleration of the box? Solving for the acceleration of the box, we could actually use this equation. Okay, so we would just wanted to know the acceleration of the box, so we have to use this one. The force applied is F1 or F net. F1, we will going to neglect the fraction, and then the mass of the box divided by the mass of the box, and that is how we solve the acceleration of the object. Note, so always remember that for second law, for uh, there is only acceleration. There is only acceleration when the F net is not equal to zero. Okay? This is the only time that we have acceleration. So we could only get acceleration if the F net is not equal to zero. Okay, let's proceed to the third law. Is the law of interaction. So what is this law? Um, the law of interaction states that, so this states that in every action there is an equal but opposite reaction. What do we mean by this? So in every action there is an equal but opposite reaction. Okay, let's say we have here a piece of wood, okay, a good piece of wood, and let's say we have here, no, this will be our nail. We have here a nail, and we will going to uh, hammer um, this nail. Okay, we're going to hammer this nail. Now, the action here is actually the force applied by the hammer to the nail. So what's going to happen here is that we have here an action. So we exert a force here, that is the action. So let's say this is our FA. Okay, so we exert a force uh, in this onto the head of the nail. When we exert a force that direction, at the same time the nail will also exert a force but in the opposite direction, and this is what we call the reaction. So this is our action and this will be our reaction. Okay, so this F of A must be equal to F of B, so they must have equal in magnitude. However, F of B must be in the opposite direction. Okay, and this is our third law, the law of interaction. In every action there's an equal but opposite reaction.